Right, in this vector diagram, there are lots of information. We need to look at these carefully. First of all, it tells you in the diagram that O to A is called 3A, that one there. And then from O to B, I'll write it down, O to B is called 5B, right? From here to here is that. But from here to here, it's just that. Some more information, right? O to D, and then D to A. That's one part, that's two parts. Okay, one part is O to D, and then D to A is two parts, two parts there. So that's 1, 2, 3 parts altogether. There's 1 plus 2 makes 3. 1, 2, 3. That means O to D is going to be not 3A, it's going to be divided by 3. That's just going to be A. Right, what else can we tell? Right, O to B, B to E. So O to B is 5 parts there, and then B to E is just 1 part. Altogether we've got 6 parts. That's 5 plus the 1. That makes 6 parts. That means B to E, it's not going to be 5B, it's just going to be an extra B plus B, because 5B plus B makes 6B, 6 parts. Right, we have here O to F, and then F to B. That's 2 and 3 parts. 2 parts for the O to F, and then 3 parts. 1, 2, 3 parts from F to B. F to B, 3 parts. F to B, 1, 2, 3 parts there. Right, first thing I want to work out, the easiest question to work out is A to B. A to B, to get from A to B, we go this way in the opposite direction of the arrow, so it'll be minus 3A plus 5B. There. Right, what if I want to work out O to M? Right, where M is the midpoint. That's the midpoint of A to B, of A and B. So I want to work out O to M. I've got 2 options here. To get from O to M, I can go from O to A and then from A to M, or I can go from O to B and then from B to M, whichever. Right, to get from O to M, I'll take this route. I'll take O to A, followed by A to M. O to A, we've already got as 3A, and then A to M, well, A to M, it's in that direction. It's going to be half the size of A to B. Remember, A to B, we've got that over here, but A to M is going to be half of that. You can simplify this. Half times 5, 5 over 2, and then half times negative 3, if it's easy just to work with numbers, I can just say that's 2.5b minus 1.5a. You can simplify that. 3a take away 1.5a is 1.5a. 3 take away 1.5 is 1.5. Plus the 2.5b. There you have it, O to M. Prove that D to F here is parallel to A to E. I've got to prove D to F is parallel to A to E. So the two vectors that I get, one for D to F and one for A to E, will look very similar. But first of all, work out D to F. D to F is D to O and then O to F. D to O and then O to F. Remember I said O to D is A, but we go in the reverse direction, D to O. In the reverse direction, that will be minus A. Now I've got to work out O to F, that bit there. But you got to remember that O to B is given as 5B. 1, 2, 3, 4, 5. 5 lots of B's. So O to F is just going to be 1, 2, 2B. You can reverse them. There, that's D to F. We'll save that. Oh, we'll need that later. What I need to do now is work out A to E. Remember, that's what I want to work out, A to E. A to E, I've got to go this way, and then I've got to go all the way that way. To get from A to E, it'll be in the reverse direction of 3A. That'll be minus 3A, and then it'll be, remember, O to B is 5B, and then B to E is another B. So that's 5B plus 1B makes 6B, right? Altogether, that way 6B. Just reverse this. And what I will do now is I'll factorize this. It's factorizable. Right, what goes to 6 and 3? Obviously 3. 3 times something to give me 6B. 3 times something to give me 3A. It's just that. So we save that now. A to E is that there. Now let's have a look at the original problem. Prove that D to F is parallel to A to E. But if you look at this part here, let me just highlight that for you. Look, same vector, 2b minus a, 2b minus a. That means both vectors, D to F, A to E, are in the same direction. Therefore, if they're in the same direction, that means they're parallel. Except that this one, A to E, is 3 times as big. That's all it is.